Folks, I don't know why that last video just stopped right there. So resuming where we left off, and unfortunately I already worked through the rest of these problems, so I'm going to be talking over the solutions here. So if we plug in negative infinity for x, we would get negative infinity, or positive infinity. So 3.5 over 1 plus e to the infinity. E to the infinity is just getting larger and larger and larger, turning into a giant number. And if I add 1 to that, it's just a really giant number. So even though this isn't purely rational, I can still use how the rational function behaves to figure out an asymptote or where my function is leveling off. So when I plug in infinity, this is getting really, really large. So 3.5 over 100, 3.5 over 1,000, over a million, which means it's getting to be a very, very small piece of pizza or a very small fraction. So as we go towards negative infinity, because remember that's what we plugged in for x here, our function is getting closer and closer towards 0. Now we can see this from our graph. It does look like our function is leveling off towards 0 there as we go towards negative infinity. As we go towards positive infinity, maybe it's leveling off at 3, maybe it's leveling off at 4. If I look at my table, it looks like it's leveling off at 3.5. So if I were just using my calculator table, I would probably say, yep, 3.5. But we are going to see how we can plug in infinity and kind of see algebraically why this works. So if I plug in infinity for x, we get 3.5 over 1 plus e to the negative, which is already in the problem, infinity. Now e to the negative infinity, that gives it a bad attitude and sends it to the downstairs of its own fraction. So 3.5 over 1 plus 1 over e to the infinity. Now, this little fraction piece is going to be approaching 0, just like this fraction as a whole in the last part was approaching 0. 1 over 100, 1 over 1,000, 1 over a million is a very, 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 very small number, getting closer and closer to 0. So as this gets closer to 0, what I'm going to be left with is 3.5 over 1, or just 3.5. So this is how we can kind of reason our way through it algebraically, but we can also see that this makes sense with what our graph is showing us and also with our table. Now, something that I am not totally sure on is why our calculator is giving us an error here. I think that maybe when we plug in negative 100, 1 times 10 to the negative 43rd, that's getting pretty small. So I think your calculator is giving you an error just because these numbers are getting so incredibly small with larger and larger e to the power of exponents, and that's why it's giving you an error there. So this is why, folks, it is a good idea to look and see what your graph appears to be doing and also using your table. So hopefully that clears up what is going on with number 4. Now on number 5, this one is purely rational. So when we go to compare those degrees, we would say that this is top-heavy because x cubed is bigger than x squared. Now, top-heavy equations are going to have slant asymptotes. So we would have a slant asymptote at y equals. Now, a few chapters ago, at the end of the last term, we can find the equation of the slant asymptote using long division, but let's not do that because we don't actually need to find the equation here. We just need to know how the function is behaving as we go towards negative infinity to positive infinity. So when I type that equation in on my calculator and we look at it, what we can tell is that we have a slant asymptote going up and to the right. So our slant asymptote has a positive slope, and that's really all we need to know. So yeah, we could find the full-on equation for that, but in the context of end behavior, we really only need to see if it has a positive slope or a negative slope. So since my function is going to be following that slant asymptote down, 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 down as we go towards negative infinity, this end behavior would be negative infinity. Then my function is going to follow my slant asymptote going up towards positive infinity. So that's why this end behavior is infinity. If we look at our table, we see that as we plug in larger and larger values, we're just continuing to get larger and larger numbers. Same with those larger and larger negative values. So it's just getting larger without bound. So with slant asymptotes, folks, you'll always have negative infinity, positive infinity, or if the slant asymptote is going this way, then your end behaviors would be flipped. This one would be going up towards positive infinity, and that one would be going down towards negative infinity. So yeah, later on we will be finding slant asymptote equations again, later on meaning in your calc classes, but it's not something we need to do on this particular problem. All right, moving on to number 6. So on this problem, if I look at the graph, what's interesting about this graph is that it just kind of stops here. So it doesn't look like it continues to level off as we go towards negative infinity. It's just kind of stopping there. So that's a little bit weird. As we go towards positive infinity, however, it does look like my graph is leveling off towards 0. So looking at my table, it does look like we are leveling off towards 0. My numbers are getting smaller and smaller and smaller. But as we plug in more and more negative numbers, we are getting an error. So let's see if we can figure out why the end behavior is DNE and 0 for this one. So first, I started by plugging in negative infinity for x, similar to what we did up on this problem. So the square root of negative infinity over negative infinity minus 2. Now, hopefully some red warning lights went off in your brain going, ding, 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 square root of a negative, that's a bad thing because we would get an imaginary number. So this is why we are getting an error as we move in the negative direction, because my function goes imaginary here, and so it is off the grid. It's off our coordinate plane. Nothing is happening there for those imaginary values. So as we go towards negative infinity, my function just stops existing because it goes imaginary. So that's why the limit as x approaches negative infinity does not exist. So moving on to the next one. If we plug in infinity square root, and then infinity minus 2. If you're looking at those going, well, I'm pretty sure infinity is going to be bigger than the square root of infinity, you would be right. So the bottom is going to be getting larger faster than the top. But another way you can view this problem is by changing the square root into an exponent. Remember, to do that, we do the power divided by the index of the radical. So the square root of infinity is the same as infinity to the 1/2. So if I compare infinity to the 1/2 over infinity to the first, this would be bottom heavy because this infinity has a larger power than that top infinity. So that means the bottom is getting larger more quickly, and thus we would have a horizontal asymptote at 0. So that's why this graph is leveling off towards 0 on the right. Now, we had to be careful on this one though, because it's not leveling off towards 0 on the left side, because that square root on the top is making our function have to consider that imaginary unit. So we are still kind of using the same rules for behavior within a fraction. However, we also need to consider what e is doing or what the square root is doing in these not pure rational functions. So hopefully that sheds some light on those bottom problems. And again, folks, as far as work goes on these, you may have just used your table ask or your graph, which is totally fine. So I wouldn't expect you to show this plugging in work unless that helps you. All right, thank you.